Welcome back to I Squared, Incidental Information, and I'm Mark, if you're new to the channel. And the whole point of this channel is to share information. Things you may or may not see on the internet, or sometimes I've seen some things that are more poorly done than I do them, which is pretty bad. But I don't tend to redo too many other people's information unless it's actually bordering on dangerous. But today was something simple, and I don't know that I've seen this too often, but today we're going to show you how I put on a PL259 on a piece of RG8 coax. It's pretty straightforward. The iron I'm using today is a 1/4-inch tip on a Weller 80-watt iron. This is temperature controlled. It's magnetically controlled. And I've had this iron a long time, and it works pretty good. And I'm happy. There are a lot fancier irons out there today, but this works fine for me. I got lots of tips for it, different sizes and lengths, and thin ones and thick ones. So today we're going to use the big 1/4-inch tip. We need lots of heat. And so this is the cable that I unceremoniously ripped from its connector by trying to pull my antenna through the trees, and that didn't work. We're doing some antenna work because I didn't quite do what I should have the first time, and I wanted to get my antenna up into its final position now that the leaves are down. I slacked up my my dipole end poles, and one of them didn't slide through the tree. Let me show you the mess we got here. Here we are down at the pond, and it's partially frozen, and the two pole lines, they're just utility lines, not hoist lines, so I just let them hang most of the time, but they're useful for pulling the antenna in to work on it, and positioning it, and sliding it around limbs and stuff as it's being hoisted. Well, those two lines were not tied off properly when I put the antenna back up, and they got frozen into the pond, so I was forced to tug on my antenna using the coax. I know, bad idea. Well, I pulled the coax out of the connector. But that's not why I'm down here. I want to show you my philosophy on sealing coax and cable connectors from the inside out, and the proof is in the pudding, as they say. So let's look at this antenna. This is my antenna center insulator. This is 160, 75, 40, 20, 15, and 10. Those are all my elements on this multi-band dipole. Now they're 1 inch apart here, but obviously they're you can see they're about 5 inches apart as they go through the spacers. So here's what I want to show you. Look at how corroded this is. This antenna was under. This is not a salt marsh or anything. This is highly mineralized water. We have a lot of iron and a lot of different salts in the water, in the surface water around here, and a lot of iron in this one. And you can tell. Now this antenna fell down, and it was in the pond for about, I don't know, 6 or 7 weeks. And you can see how the salt in the water has attacked the aluminum box with the balun in it. And it's all functioning fine. Yeah, all the connections have a little grease or something on it. But here's the thing that I really want to show you. This is like the proof is in the pudding again, as I said. Now, I haven't opened this up yet, so if it proves me a liar, you won't be seeing this video. But I'm pretty confident that once I get this off, which is going to be, yeah. Let me put the camera down and I'll break this free for a sec. Okay. That didn't take long. That's pretty clean. There's a little corrosion in the threads, but that connection is clean. The white waxy stuff you see there is the silicone grease that I use. And you can see there's really no corrosion in there. It's a little discolored. It's a little surface oxidation, but there's no corrosion. Let's look at the condition of this connector. Okay. There we go. There. Focus a little better. So, 6 to 7 weeks under salty water. Pretty clean. You can see the silicone grease that I use inside. So what's the coax look like? Remember, that's the outside. There's the inside. Let's go take a look at the coax. So there's the connector. Here's the coax. Here's the center conductor. Look at the condition of the center conductor. Pretty clean. Now I haven't touched that. All I did was yank it out like an idiot. The solder braid, I see a little, might be a little corrosion in the, no, the aluminum looks pretty good too. And I just stripped it back a little bit so you can see what this braid looks like under here. And there you go. So no water infiltrated through the connector into the cable. Like I said, 6 to 7 weeks under rather briny water. So here you go, folks. Seal your coax from the inside. There was nothing on the outside of this connector. Nothing. Well, there was something. There was a piece of PVC. I have a 2-foot piece of 1.5 inch PVC that slides up over the bottom of the coax, which is just to provide some ballast so that the coax is tipping that plate down towards ground with a little bit of leverage, a little bit of torque. It's sort of a torque arm, but it's open to the weather, completely open to the weather. No coax seal, no elephant dung or whatever the hell they call that, plumber's putty or any of that crap. This is sealed from the inside by loading it up with dielectric grease. Proof is in the pudding. So we're gonna start over. It doesn't really matter where I cut this, I just need to get this end off. So good old pair of pinch type diagonals work just fine. I'm gonna move my iron out of my way over here. So I'll be working here. So you can use a razor knife. I think they work fairly well. And what I'm going to do, the first thing I'm going to do is I'm going to make a line through my insulation and try to meet up with it on the other side. So that's my guide. And then I'm just going to slice my knife through the braid and shield all the way around. I don't want to go down to the center of the coax. I don't want to nick it. And you can kind of feel when you've gone through the insulation. And now I break it free. Oh. So that came off. Got a couple of hairs I didn't cut. There's a little tiny bit of corrosion under the braid on the aluminum, but that's okay. So now I'm going to grab my inside insulation and just twist it free and pull it off. There you go. Alright, now look closely at your, before you cut any more insulation off, look closely at your center conductor and shield and insulator. Make sure you haven't pulled any wires in, created any shorts. You got a nice clean insulator there. So now we're ready to take off again. Now this time I'm not going through the insulation, I'm just scoring it very deeply. It's a very deep score, and I press my blade into the side. I don't slice this, it's just pressure, and you can feel it sort of pop through. Okay, and I peel this off. I don't pull, I peel. If you pull, you're liable to undo the braid. The braid will separate on you. So I just peel this off very carefully. Okay. Now I have a nice shield. Now I am going to use a little tiny bit of solder paste, just a film, I mean just a tiny bit, because this coax smeared on my fingers, and just a tiny film on the coax, maybe a little more. Just dab it on, just a thin film, because this shield has been exposed to some weather. I know there's some moisture has gotten in there. Don't forget your threaded shroud. And now the connector. And it just screws right on there. Don't worry about the length of your center conductor yet. This can get pretty tough once you get down a few turns. And once it bottoms out, you'll feel it. There we go. That's bottomed out. So there's my shield showing through the holes. Okay. Alright. What did I drop? I dropped the pliers. Don't need those. I will solder this last. This is the easy part. Leave it long. You can apply heat to that and let it act as a wick, suck the solder in before you apply heat to the tip. So the heat will transfer from the center conductor to the tip once the solder fills that. You don't want to do it upside down either. You don't want to fill it like this, because then you actually can get enough solder flowing down, especially if you're using the new ROHS solder, which doesn't contain lead. The new high antimony solder contains a tin antimony. It's very, very fluid. It's not lead solder. I mean, I guess it's a pretty good substitute, but it's very, very fluid. It does not have the wicking and the adhesive capability of lead when it's molten. The molten lead tends to have a little bit more surface tension. You know, it tends to hold itself in a joint better than the new stuff. But I'm using the old stuff. Speaking of which, where is that? There we go. It's in this pocket. Okay, so now, don't need this anymore. This is nothing special. It's cheap knife, hardware store knife. So now I'm going to clean my tip. By the way, I use ammonia, just regular household ammonia and water on my soldering iron sponges. Works very good for cleaning, keeping your tips clean. I always leave my tips well tinned before I let them cool. So now comes the fun part, and that is heating the connector. Get my heat in there. Now, because this wire is buried in the backyard, I can't bring the wire into my shop. It's not long enough, and I don't want to unbury it. So I just folded back the aerial part back into the house. So I'm working in the vestibule of my basement, and I don't really have everything I would like. Okay, so we're just waiting for the 259 to build up some heat now. It'll take long. There we go. So I've got all my holes painted over. Little convex plug of solder on each one. Now I'm ready to move on to my center conductor. So heat the center conductor. So we're going to load this up with plenty of silicone grease and screw it into our antenna now, and we should be good to go. I will do a quick test with a 50 ohm load on here just to make sure I don't have any nasty surprises. Thanks for watching.